Hello, and welcome to this Claris Engage session, Start to Finish Machine Learning Models. With the release of CoreML features in the FileMaker platform, it's never been easier to integrate incredibly complex computer algorithms with your custom apps. So in this session, I'd like to introduce you to how you can use CoreML features in the FileMaker platform, what machine learning is and what machine learning models are, how you can train your own models so you can use your own models in your own custom apps. Then we'll talk about how we can extend machine learning beyond the context of FileMaker. And lastly, we'll take a look at some resources to help you along your journey in integrating machine learning. Along the way, we'll use the session materials to guide you through some demos of how machine learning is implemented in the FileMaker platform, as well as where you can find resources for further assistance. As an introduction to machine learning, I hope you find this course easy to follow. The main two takeaways of this course are how to use CoreML features with the FileMaker platform, as well as how to train your own models to use in your custom apps. If you have any questions, the community and myself are here to guide you. Let me introduce myself. My name is Mike Beargie, and I'm a senior application developer and product manager at MainSpring, a Claris Platinum partner. I'm happy to contribute to the Claris community. Aside from being on the community MVP team, I also test the latest versions of FileMaker. As a senior application developer at MainSpring, I develop high-level custom apps for our clients. I also take on mentoring of other developers to help them improve their developing skills on the FileMaker platform. My role also includes project management using the Agile methodology. And as the product manager for our FileMaker server hosting and vertical app experiences, I help thousands of users get value from the FileMaker platform with a streamlined experience. But it's not all about business. I like to have fun as well. When I'm not sitting at my desk, you can find me leading a jazz band on my saxophone, working on my latest woodworking project, or behind the wheel at the seat of a race car. As a speaker at past FileMaker DevCons, I'm super excited to be a part of the new Claris Engage. To follow along in this course, you're going to need a few things first. Obviously, we're going to be working on Mac OS. During this course, I'll be working on an iMac, late 2015, 32 gigs of RAM, and a quad-core processor. But as long as you have the minimum requirements that will run Xcode and FileMaker Pro, you'll be good to go. Also note that I'm using Mac OS Catalina at the time of this video because Xcode requires Catalina. So first place to go is the App Store. You just want to search for Xcode. You'll want to install or update to the latest version of Xcode. With Xcode installed, you're just going to want to launch it out of your dock or your applications folder. Xcode is a free program, but there's also an Apple developer subscription. We don't need that subscription for using the tools that we're going to use today. So all you want to do in Xcode is go under the Xcode menu, go to Open Developer Tool, and open the Create ML tool. And you might want to right-click on this, go to Options, and go Keep in Dock. That way, we can use the Create ML tool later on in this course. The last tools you'll need to complete this course are the Claris FileMaker Pro platform tools. Now, I've got version 19 installed at the time of this course, but any version after 19 will work. You'll want to make sure that you've updated to the latest version for your system. Optionally, you may also want to install FileMaker Server for Mac OS and FileMaker Go for iOS in order to test out machine learning integration. Be sure to download the course materials zip file. This is going to contain a folder that includes demos that you'll see throughout the course, a course guide detailing all parts of this course, as well as sample data that we're going to use to build models. We're going to start off by defining machine learning. So what is it? Machine learning is the science of developing algorithms, or models as we call them, that can improve automatically through experience. Experience is gained by these models by giving them and training them with sample data. Once they've been trained, machine learning models can be used to identify characteristics about other data that's given to it. As a subset of AI, this has tremendous applications, especially in our custom app department. The type of CoreML models that we're going to develop are called supervised models. They're supervised because we provide the data that trains them. Those models can then later be used to identify similar characteristics about data that we feed to that. This is an important difference than unsupervised models, which aren't trained in the same way. Those unsupervised models are trained to identify patterns about data with no previous training about characteristic development. So while supervised models might be used to identify if a picture is a cat or a dog based on training of pictures of cats and dogs, unsupervised models will be used to find objects in a picture based on finding outlines of the picture or pattern recognition. So most people are surprised to learn that they're already using apps that have machine learning in them. Say for instance the camera on your phone. When you tap a picture, it might outline the faces that are in your picture so you can focus on those. That's a type of machine learning that is identifying the faces in your photograph. Machine learning is normally used for one of two different things: the analysis of data to find specific characteristics about it, or for the prediction of an outcome based on a known set of parameters. Since the FileMaker platform can integrate both vision and general models, it can be used for both the prediction of results and for the identification of characteristics about data. So CoreML utilizes two types of models: vision models and general models. Vision models are used to analyze things like images, sound, videos, or other types of media files. While general models are used normally to analyze text or to make predictions based on a set of parameters. Some examples of using a vision model would be if I wanted to identify what type of car was in a picture. If I'm walking through a warehouse and I picked up an item off the floor and I needed to find out where to return that, I would be able to take a picture of that and identify the part and where it was located. Maybe I need to take a look at an image and identify how many people are in it, so I can filter out pictures that only have 3 or more people. All of these can be achieved using a vision model. Vision type models are also already widely in use in the industry today. Let's say, for instance, you need to be able to scan hundreds of thousands of pictures and automatically flag ones that have violent or pornographic content. Vision type models would be able to do this on a large scale. Like vision models, general models can also perform very complex tasks. For instance, if I wanted to check every inbound email that I get, analyze if it's urgent, and then move those urgent emails to the front of a queue, I can do that with sentiment analysis and general models. But general models aren't only about analysis. They can be used for predictions as well. At a very high level, this might be something like weather forecasting or stock market predictions. But at a lower level, this can be used for a variety of applications, like predicting the price of real estate in a specific area, or even something as fun as picking the next quarterback in your fantasy football team. Now that you know what machine learning is, let's see how you can integrate it with your custom apps using the FileMaker platform. So let's demonstrate just how easy it is to integrate CoreML and machine learning into the FileMaker platform. So I'm going to open up FileMaker Pro and I'm going to create a new content management file. I'm using content management because it's already got an image built in, a container field that I can use to perform machine learning analysis on later. So I'm just going to save that into our folder here, and it will give me this nice starting point. So from here I'm going to create a couple records, and into each one of these I'm going to insert a picture into these. And I've got a sample cars folder with some free pictures of cars that I found online. So let me do that. This one's actually an illustration, a vector illustration, but we'll talk about that in a minute. And the third one, that is a transparent PNG as well. So the type of data you analyze can make a difference as well. So if there's a transparent background versus a solid background or a pattern background, or if it's an illustration versus a picture, or if it's just a picture depending on what angle the thing is you're trying to identify. So in this example, we're going to learn how to use machine learning to identify what type of car is in the picture that we have. So the first step to integrating this is going to be to find a place where we can store our models. So I'm just going to add a new table to my database. So I'm going to go to Tables, Create. I need to give it a name first. Let's call this Models. Create that. And then under the Models table, I'm going to create a model field. This needs to be a container field because our models are files that we need to store. And let's go ahead, for the sake of it, I'm going to give it a name as well and create that. Now, of course, FileMaker is going to create a layout for me. So I'm going to go to that model's layout. I'm going to create a new record here. And I'm going to call this Cars Identification. And then under Model, I'm going to insert our model. Now, this is a model that I found for free use online. I didn't train this model myself. And later on in the course, I'll show you how you can find your own models to use online that are already pre-trained. So I'm going to insert this into my container, and now I have it in my custom app ready to use. So I'm going to return back to my detail view here, and we're going to get started on scripting this. So under Script Workplace, I'm going to create a new script in here, and we're just going to call this Analyze Car Image. So the first thing we want to do inside of this script is load that model that we just put into our models table. So I'm going to comment here, load the model. So this will be pretty easy here. You can just go to the model layout. We're going to do a find for our model by name. So let's find our model by name and say car identification. Perform find. You could do further error checking here. If you had a table where you were storing many models to use, you could make this a dynamic script to load a model based on some parameters. Really, there's so much you can do here with FileMaker's platform. But for now, we're going to focus on just the machine learning aspect of this. So I'm going to use a script step called configure machine learning model. And this is going to allow us to load our model. Now remember, there's vision and general types of models. And depending on what you load will depend on how you can use that machine learning later on. So we're going to use a vision model here because we're trying to identify a car from a picture. So for name, I'm actually going to give it our name of our model, and that will load it into place here. But what's even better than this is actually putting this in a variable. So I'm going to call this $model name. And we're going to do just a quick set variable model name, and then put that table and field name in here. And the reason I'm going to do that is because we're going to be referencing this model a couple times. So putting it in a variable name here makes sense. So the one last step I have to do here to configure the script step is tell it to load that model from a container field. So I'm going to choose my models table here and load that model. So what we've done to this point is we've loaded this model, we've made it ready to use in our system, and we've assigned it to a name of $model name for our variable name. Now we're ready to return and start using that machine learning model to perform machine learning functions. So I'll stick a comment in here, return and analyze image. So we're going to go to our original layout that we came from because we're going to attach this to a button later. And now we're going to actually put this model to use with a function called ComputeML. So we're going to put this into a result variable. So set variable $result. And now in the calculation engine, I'm going to use the compute model function. So here it is under miscellaneous. Now there's a couple things here to think about. One of them is that this takes an endless number of key value pairs, value 1, name 1, value 2, name 2, etc. It's expecting multiple parameters, but what do those parameters look like? Well, FileMaker Online gives you this documentation example. I'm going to paste it here so we can see it. We're going to compute a model. Model name's easy enough, right? We already used model name, so all we do is put a $sign before that. Now we're going to need an image that we want to put in here as our first key value pair. So the first thing we're going to do is image. And then we're going to use my image field. Well, in content management, that's this file container, so I'm going to put that in there. Put another semicolon there. Now, everything really after this point is optional with vision models, but it's a good idea to specify some stuff because you can come up with a lot of possibly garbage depending on what model you're using. So maybe you want to set a threshold that says, I want you to be 50% or more certain of something if you're going to return that result to me. And that's done with this threshold here. So we'll put threshold in here. And this is a value between 0 and 1. 1 being 100% sure that it is this thing, 0 being 0% sure. So in our case, I want to return everything that is maybe a 0.25 or higher. Now, a warning here, well, this is a number, so I don't need it in quotes. But a warning here is if you set this threshold to 1, almost always you're never going to get a result back from a machine learning model that's 100% sure. There may be going to be 60 to 80% sure as a reasonable result. 90% sure is probably going to be a great result, but you're probably never going to find ones that are 100% sure. So if I put threshold to 1, I might return a blank result or no result from my model because there aren't any that are 100% match. So that brings us to this next parameter, and this next parameter is called return at least 1. I'm just going to copy and paste this in here. And what that does, return at least 1, is if there are no results that meet your threshold here, it will return the next best match to you. So if I set this threshold to 0.25 and there's a match that's 0.2499999 as my highest match, that match will be returned. So I'm always returning the most likely match. But if I set my threshold really high, it'll tell me what that match is. So this is all we need here. You can delimit this any way you like. Sometimes I like to return delimit here. It's Option Tab if on a Mac for you to tab in on these. So I like delimiting these parameters. And once I've done that, hit OK, and make sure to save your script every once in a while. Command S, just to make sure we've saved our work. All right, so we've analyzed this image. So now we need to take a look at what that result is going to be. So we're going to need a field to place that result for us to look at that. So I'm going to go to File, Manage Database. In Content Management, I want a result field in here. For now, we're just going to do this as text. And then I'm going to set that field with the result. Now I could do this as one line, of course. I could take this compute model and throw it in here, but as you'll see once we actually do a test run of this, you might want to have it in a variable so that you can do other stuff with it. So let's see how we're doing so far with our machine learning integration. I'm going to go to layout mode on this page. Going to create a button here. We're going to call this Analyze Image. Going to have that perform our script, Analyze Car Image. And remember we had that result field as well, so I can create a result field in here. And just go ahead and give it some basic sizing here. There we go. Okay, so I'm going to run this with the debugger turned on. That'll let us step through each part of this process. So I'm going to step through and watch how this performs. So it's going to go to our models layout. It's going to find that model. You can check in the data viewer to make sure that your model name is in here. And we're going to configure our machine learning model. And you see 0, no error. Now, you could actually see an error here. That error code is number 872. If this script step performs an action and it tries to load a model that is not compatible with FileMaker, it will give you an error message on the screen. So for now, we're going to return to the original layout, and we're going to use that compute model function here to actually analyze our image. So if we peek into our data viewer right now, we should see a result in here, and you see, wow, we see a lot of results in here. And we'll talk about that in a minute. So lastly, we'll put that result in here. So great, we got usable data back almost immediately, and it can say with a 42% confidence that it thinks that's a Benz C-Class AMG. And I know it's a BMW, so that's not quite accurate at all, is it? There are some other results in here. You can see BWM, Superior, Saab. So it looks like the model that I found online for this really isn't all that accurate. And that comes down to how that model was trained. So there's hundreds of thousands of cars in the world, different model years, different colors. So to actually train a really reliable model to identify car images would require hundreds of thousands of source images of all different angles, all different colors of cars to be able to identify them. So this is what you could call a pretty inaccurate model for identification. But at the same time, it might actually put you in the right area, because you can see that BMW, or BWM in this model's case, is here 3 times in the top 5 results. So I could use that to classify my results. Now you'll notice too, these results are in JSON format. So that allows us to do more processing with that as well. So what I can do, because the result is returned in that JSON format, is actually transform that into what I call a human readable format. So what I've done here is I've taken our set field, and instead of just returning the result, I've written a quick function using the while loop here. Now the while loop is going to loop through our resulting JSON. So let's walk through this really quick. So you can see here that to begin with, I just have to talk about what we're going to use in our function, and that is an iterator or a counter, and I'm setting that to 0 because JSON works with 0 index arrays, so it starts at 0, then it goes to 1, 2, 3, 4, 5. So we want the first 5 results. So I'm going to say that as long as that counter is less than 5, then it's going to run through the loop. So that will return to me 0, 1, 2, 3, and 4. Now I also want an empty list in here so that I can build my output. And we're going to return that list at the end down here as the output of this function. The rest of this in here is just putting everything together. So the first thing we're going to do is get each line out of the result. So each returned result we're going to go through. We're going to get the name out of there. There's a JSON element in there called classification we're going to pull out of there. There's also a percentage of confidence in there. Now that's an actual decimal, so we're going to multiply that by 100, and we're also going to round it to 2 decimal places because as you saw, it returns a very long decimal. Then I'm going to put together my text display, my human readable display. It's going to have the name followed by the percentage, that's in parentheses. And then I'm going to add it to that list. So each time through the loop, it adds a new item to my list. Then this last thing here is what iterates the counter. It adds 1 to the counter so that when this condition is met, it exits this loop. So all that together is a great way to transform that whole chunk of JSON into human readable text. So let's go ahead and save this. And we're going to go back now, and I know this is working, so I'm not going to use the debugger, so I'm just going to click. And you can see now that our results are much easier to read. We've got the first 5 cars that were returned, along with their percentage of confidence in parentheses. So that's a great, easy way to use FileMaker's built-in JSON tools and looping functions to be able to digest the information coming back from the machine learning model. So just to make sure this works, let's go check our other 2 images that we loaded as well. Remember, this one was an illustration, so we'll go ahead and analyze this. Now, I think Porsche Cayman's pretty close. So it's still not returning super accurate results, but, you know, it's at least in the top 5 results returning to us something similar. And our third one here, Benz, this one's not as great. So again, the model is going to be only as accurate as it's trained to be. That's the thing about vision models, is they don't progressively learn. You need to continue to train them and add more sources. So as we progress into the next chapter of how to train our own models, you're going to get a better appreciation for what all is entailed for training a model to make it accurate. So we've learned how to use vision models in the FileMaker platform, but let's talk about the other kinds of model, the general model. So I've made the assets file here, and I've copied some of our work over already. You'll see that in this file, I've already got my models table in here. I've changed the one table here to be reviews. And if you look in the reviews table, you'll see that the result field is in there. So my idea is that I want to take reviews about my assets here. And let's say I want to use machine learning for performing sentiment analysis on those reviews to find out if they're positive or negative. That's a pretty easy thing to do because you can determine in a language which words are positive or negative. And when there's more negative words than positive words, then you can assume that that is a negative review. And that might be something that indicates I want to follow up with the person that left that review. So I've changed the portal over here to show reviews. There's a note in here. Let's change these field names really quick. This placeholder right here should just say review, and this placeholder here should just say result. Okay, so we've got our review and our results, so that's what we're going to fill in on there. Now, in the script that I copied over, I've added a few things here. Since this is going to happen on a related table, I decided to create a new window really quick for that processing, and then that way I don't lose my context by jumping around to different layouts. And since I'm opening a new window, I've turned on some error capture and allow user abort off and committing of the record, so that I can make sure that that record's saved before I perform the script. So you can see the rest of it is pretty much the same as what we already did. We go to our model's layout, we find the model we're looking for, we're going to load that model. The difference here is that instead of a vision model, it's a general model, but it still takes that model name parameter from our variable, and it still loads from the same container. Now on to analyzing our review. So we're going to go to the reviews layout. we're going to enter find mode, no pause there since this is scripted. We're going to find our review, which is going to be reviews primary key, and we're going to pass that in with an ID variable in JSON later on. We're going to perform a find. We're going to set a variable of our review, the text of our review, so that we can analyze it. And then we're going to, all at once, we're going to perform that machine learning here. So in the reviews result, you can see we're doing this calculation of JSON get element, and we want to get the label element out of the result of our model. And our model is just plain and simple. There's no threshold here. There's no limit here because remember it's a general model, so it's not going to return to you 50% match, 60% match. You can train these models to do different things. This one's just going to return to us, is this positive or is this negative? So it really doesn't have any threshold parameter that we need to pass. And that's why this compute model is flexible to allow multiple parameters. So for this one, we're feeding it a model name, we're feeding it a text parameter, and we're feeding it our review. And from that, it's going to spit out, is it positive or negative? Then to finish up here, we're going to return and refresh, close the window, and refresh our underlying window. Now, one thing I didn't talk about when dealing with vision models was unloading models. So why are you going to want to unload a model when you're done? Well, if you think about how machine learning works, we're going to configure that machine learning model. It's going to load that model into our computer's memory so that it can run analysis actions against it. So as we use that model, it's taking up space on our computer's memory. So we want to unload that model to free up that space. So that's also super easy. We just run the configure machine learning model script step again with the default of unload, and under name, we just give it our model name that we've been using all this time. So we're using that model name throughout our script here, so that's why we're setting it as a variable up here. So it makes it easier for us to use rather than hard coding it everywhere. So unloading that model frees it up, and that makes sure that we're not bombing our system's memory. Some of these models can be very huge, 400, 500 megabyte models, especially the vision models. So you want to make sure that you unload it when you're done. So let's see how this works. I'm going to open up my debugger here again, and we're going to type in this field. You can see that our script fires off, so we're going to follow this through. There's our new window that we're doing the processing in. It found the model okay, so it's going to go ahead and load that model. No errors there. Now it's going to find our review. You can see there we took a JSON parameter of ID. If we looked at our data viewer, you would see that this was our parameter that we passed in here. So it finds that record. It's going to set that review, our test note in here, and it's going to run that result. So it just says it's a positive result. Closes that window and then refreshes and unloads our model. So there we go, test positive. So let's try writing a negative review, like, this car sucks. I'm sick of it cutting me off on my way to the store every Friday. So I'll leave that review, and there we go. That comes back as a negative review, because what it's doing in this machine learning model is it's taking out the words that really don't mean anything of it on to the, those words that don't really mean anything. It's not checking those words. And then it's giving a score of positive or negative to all these other words. So I've got sucks and sick of it and cutting, and those are negative words. So the negative word score comes back, and if it's more than 50%, it's going to be negative. If it's less than 50%, it's going to be positive. There are some more advanced sentiment analysis that will give you a score along with that. This model that I found does not do that. It's only positive or negative. It doesn't have a neutral, it doesn't have a middle ground, it doesn't have a score. So for my purpose here, it's just some basic sentiment analysis. And since I have it to a trigger, I can have that run every time I change that content. So that's how we integrate machine learning into the FileMaker platform. It's pretty easy, right? This was just a basic introduction for how to use these functions and the script steps involved in using machine learning on the FileMaker platform. But I hope you'll take this a lot further because this is super advanced stuff that it's capable of. And now that you know what FileMaker is capable of in integrating machine learning, we can move on to the next step where we're going to learn how to train our own models to use, where we can control the parameters that we receive and control the output of that model for analyzing data. Now that we've learned how to load and use machine learning models in our FileMaker custom apps, you might be wondering, how are those models created? In this chapter, we're going to learn how to train our own models, both vision models and general models, for us to use in our custom apps. We're going to do that using a free utility that's released as part of the Xcode platform from Apple. It's time to start training our own models, and to start, I want to show you a model that's already in progress, because this comes with a great warning about model training, and that warning is that it takes time. This model has been running for about 3.5 hours now, and you can see it's done training about a third of the way. Now, the reason it does iterations and loops over it is because that makes it more accurate. For each time it goes through the training process, it becomes slightly more accurate. So there's different algorithms that CreateML's app can use in order to give you different results in accuracy. So that might be like keyword matching versus matching in the context of an entire sentence. So with that in mind, let's start creating our own model. The first thing we need to do to train our model is get our data together. So it's not even in this app at all. So I'm going to go to this folder where I've assembled some data for us to make a vision model. Now you'll have access to this data as well, so you can follow along. But this training data consists of a ton of files, 169,000 files, 1.62 gigabytes of images. And if we go in here, we can see that all of these are folders. So each one of these folders represents a data point that can be identified. And inside of each folder are different pictures that can be used in training to match this logo. So I'm here in the A bike folder, and all of these logos in here have to do with A bike. They are all logos that have been used by this company. So what we're going to do is we're going to train a model that can be used to identify logos of companies. So inside of my training data folder, I have a folder for each company we want to identify. And then inside of each folder for each company, we have the images that identify that logo. For more information about this source, be sure to read the README file inside of here. This includes attributions as well as the license purpose here. Once we have our data together, we're ready to actually go create our machine learning model. So I'll go back into CreateML. I'm going to go under File, and I'm going to choose New Project. Now this is going to give me a set of templates that I can use to create my model. The two that we're going to do are a vision model that uses the image classifier template, and also a text classifier model inside of this text area. So let's do the vision one first. So I'm going to choose image, image classifier, and next. It's going to ask me for something, so I'm going to call this logo recognizer. It's going to ask me where I want to save this, so I'm going to choose my vision model data folder, and I'm going to save it here. So this has opened a blank template that I can now use to train data. Now, you can train multiple model sources inside of the same project, but each one of these model sources is going to generate your output, your .ml model file. So all of the data I want to train, I'm going to click and drag into this training data folder. So let me go in here to my vision model data, and I'm going to drag my training data folder directly into this app and drop it here. When it's done loading your folder, there's a couple things to look at here. The first is the number of classes you have. Now that's going to be the number of different types of outcome from our model that there can be. In our case, it's going to be the number of logos that it could possibly be, the number of companies, 2,338 companies. Then our training data is the amount of items we're going to train with, 166,891 images in our training data. While it's training the model, CreateML is going to actually validate the data. Now, I can use my own set of validation data that's maybe a smaller set of data, but if you automatically set it, it's going to use your training data, and it's going to test that training data against the model as it goes and see how accurate the result is. Testing data for now we're going to leave blank, but you can also fill in testing data at this point if you want to. The parameters here for maximum iterations, that's how many times it goes through, how many passes it does of training on these 166,000 items. But in our case, we can maximize it at 25. In our case, we'll probably set it something lower, maybe 5 would be good enough for us. We can also do augmentations to our vision data. We can say we want you to add some noise, or we want you to blur, flip the images, or rotate the images. And what that'll do is it'll take each one of these images as it trains and perform some of those augmentations so that if you get an image that's slightly rotated or blurry, it's still going to be able to figure out what that is. So it's super powerful features built in with these augmentations. So that's it. We are ready to train. So all we have to do now is maybe save our project just to make sure, and then hit the play button for training. Now this part's going to take a while. This is queued because I'm still running my sentiment analysis training. So for now, I'm just going to queue it, let it run, and come back when it's finished. It's now been about 17 hours since this model started training with our images. So you can tell when you have a lot of data, you're going to need a really strong computer to train your models, or you're just going to need to minimize it and let it run for a long amount of time. If you have less data or text data, maybe it'll take less time to run. So here's a completed model we'll take a look at. This is our sentiment analysis model that I'll be showing you a little later, and this trained in about 10 hours. And if we go back to classes, we can see that was 3 classes, positive, negative, and neutral, and it was 75,000 text files that we trained with. Now, these metrics that you have here are the training accuracy and validation accuracy. So as it's training, it's validating against itself using the training files to see if the model's able to come back with the precise result. So in our case, you know, it says we got about a 87% training accuracy here after our 75 iterations. So we're going to take a look at that in a minute here to see how accurate that is in our file while using that in our custom app. On our logo recognizer project that we were training before, you remember that the full data set was taking a really long time to run. So in order to complete that, I took it down to just 5 logos to check. Those 5 logos had 423 pictures, so it trains a lot faster. This one completed in 17 minutes and 59 seconds. So in this case, you can see that the training accuracy, the validation accuracy hit about 55%. So once it starts leveling out this line for training accuracy, it'll stop training automatically because it's not going to see any improvement after an amount of time. An easy way to test is directly in the program. So if I click on my output over here, you can see that I can test pictures right in here. So all I have to do is hit Add Files, and I can choose a file from my smallest data set here. So if I choose Aveen, I can choose one of the Aveen logos in here, open that, and you'll see that it comes back with a 90% confidence that that's Aveen with a 9% confidence of Aurora. So we are getting pretty accurate results on the smaller set here. On this Aurora test I did, it was a 77% confidence with some other ones returned as well. So in this case, this result is a pretty good result for what I was looking for. I could use this model, but right now it's only trained for 5 classes, 5 logos. So I definitely want to start adding more to this in order to make this a really good model. If you remember, I was training a general model as well. It took 9 hours to train. I've actually done it a few times now, and I wanted to detail kind of the data set that I used for that. It'll be included in here so that you can actually process this yourself as well. This data set is made up from 1.6 million tweets from Twitter that have all been categorized as positive, neutral, or negative. And that's what we're going to use to train this model for sentiment analysis, is that 1.6 million tweets. Now I wanted to show you kind of what that data looks like. So I've taken the test data that you would use to test this data with. It's only 500 records out of that 1.6 million. And you can kind of look into it, how it's categorized. So this was built with 3 categories, 0 being negative, 2 being neutral, and 4 being positive. And then you can see what the tweets look like in here. So this actually gives you a good foundation for testing a more concise sentiment analysis rather than just using keywords, because it's actually using natural language to train with. So we've trained this model, and the model is surprisingly only 65K in size. So we're going to go see how that's used now. So in our assets file from before, all I've done is I've created a new model record for sentiment analysis new versus the old one we were using, and I've updated our script to search for that specific model to use. And now if we go to our assets, we're going to be using that. So we can actually take some of these tweets out of here and paste them into our result, and we should get a good result, but this for some reason turned out to be negative. So it looks like something I did during training may not have come out right, or maybe I didn't train it as long as I needed to, 1.6 million, and it was taking me only a few hours to train. So if we can try typing something else like, "This is really awesome, I love it," that should be positive, and that does come out as positive. And there's a neutral category in here as well. So we are getting accurate results with that model, but there's always room for improvement. So when you're experiencing these things in real life, you have to be testing your model against your own test data, but also getting feedback from people that are using your models as well. A final quick note on this chapter is the availability of these machine learning model resources that I've been showing you today. The CreateML app is only available for macOS because it's part of the Xcode platform. But there are things you can do for Windows. First off, let's take a look at this .ml model format. This is the format that CoreML uses for its file format for models. So this is only going to work on macOS. It's not going to work on the Windows version of FileMaker or the Windows Server version of FileMaker, and that includes Linux like FileMaker Cloud as well. So you're limited to Mac servers, Mac computers, and iOS devices that can leverage the CoreML framework. Some popular things that exist for Windows and those other platforms, though, are machine learning on other platforms. Things like Python and things like JavaScript even have machine learning available now through popular libraries such as TensorFlow. So while you may be able to integrate these things into FileMaker, say in a WebViewer object or as a system-level script or by a plugin, it won't be as easy for you to integrate machine learning like it is using the CoreML framework. I've got a quick little bonus video here for you to show you some of the power of the models that you can find for free online. Now, this is a page that will be in the resources file. It's from Apple's developer program, and it's pre-compiled machine learning models. And the one we're going to use is one called ResNet 50 for doing image classification. So I can actually just download resnet50.ml model from here, and I'm going to load that into our content management system. So models, we've already got it here, new record objects. I'm creating a new script in here called classify image, and the only change I'm really making here is that I'm loading our objects model. So if we go back to the details screen now, if you remember before, this is returning to us results based on a different model that wasn't super accurate for identifying cars. So this one's trying to just find the classification of an image. So if I click classify image, which is tied to that script, you can see that now it is giving me 99% confidence that this is a Jeep and a Land Rover. So that's still wrong, but let's look through some more interesting photos that I grabbed off my Facebook page, and we'll see how it analyzes those. So this is true. This is a saxophone. It came back with only a 41% confidence, but that's my saxophone. Maybe because it's got a different finish, it didn't have a higher confidence. This is a picture of a dog that I watched, and actually it is super accurate. And that is a Basenji, which is not a common breed of dog, so it was able to guess that pretty high in the list of results as well. This was a picture I took at DevCon sometime. It was at the airport, so it's coming back with fountain as the second result. But if you look in the photo, there's actually two flower pots in the foreground as part of this photo, and the fountain's in the background. So it's kind of cool how it classifies these. This was a ski resort photo I took, and it comes back with pretty good results on that. Here's a picture of us at the county fair, and you can see it's classifying multiple parts of this image: sunglasses, dark glasses, shades. Not sure where these other results are coming from, especially Dungeness crab. If I classify this, boathouse, it sees the river in there, and it sees that there's a building, dock, palace, castle, probably because it's got these peaks. And this was what surprised me. This was a snap of my corgi splooting on the ground, and it came back with super accurate results, guessing that it was a corgi. And lastly, my cat as well. So not only is it identifying the cat in this photo, it's identifying that the cat is indeed in my suitcase, so that there's backpacks, knapsacks, rucksacks around as well as a quilt in there because it's got this pattern quilt. So this is an example of a well-trained, more highly accurate model that's been probably given a lot of consideration. I believe it said it was a 102 megabyte file. So that's pretty large compared to our sentiment analysis file that was less than a megabyte. So it's been trained very well, it works very well, and you can see that this has some real world use of maybe identifying and automatically categorizing pictures. And we didn't have to make any modifications to our script either. We just used the same while loop that we were using before because the input and the output of that model was the same. So this makes a very flexible framework on CoreML for us to be able to use many different models to get a lot of metadata about specific photos. Now that we've covered how to integrate machine learning with the FileMaker platform, as well as training your own models, let's take it one step further and look at further resources that you can use to integrate machine learning with your custom apps. All of the additional materials that you'll need are here in the course materials folder underneath the course guide.pdf. This includes links to FileMaker documentation about machine learning, the script steps, and the functions that we use today. It will link you to additional resources for machine learning, things like finding data sources that you can use for machine learning, and pages where you can download already ready-to-use models. And it will also include other pertinent links regarding this course. We're reaching the end of the course, so you might be wondering where you can ask questions and get help with machine learning. Let's review how to post questions on the community. The community can be accessed by going to community.claris.com. You'll want to make sure that you're logged in so that you can ask questions or search for topics. The first thing you want to do is search for topics to make sure that the question that you have wasn't answered before. So you could search for CoreML or machine learning or a specific error message that you're coming across. If none of those works, then you can post a new question. That's just done with this Ask a Question box right here, and it pops up a window where you can choose a new question. So new questions for machine learning will go under Claris FileMaker. You'll enter in the summary of your question, like I have a question about machine learning. And it's going to suggest questions for you, but you can just continue through this if you want to skip by it. So the more detail that you post in your question, the better. That's going to allow people like me and authors and other community contributors to help out and try to answer your question. So provide all of the details, what it was you were trying to do. If you're trying to use a CoreML model, maybe include the .ml model file as an attachment. There's a little attachments button down here. You can attach .fmp12 files. You can attach .ml model files. And then most importantly, make sure you tag your topic. And an existing topic that already exists is machine learning. So if I try to tag this with my machine learning topic, I can do that. And then when you're done, click on Ask, and then you should receive notifications depending on your settings in the community. So that's a really easy way to ask questions and get assistance with machine learning. We've reached the end of our session. As a reminder, the goals for this session were to introduce you to CoreML and machine learning, how that works in the FileMaker platform, and how you can integrate that with your custom apps, as well as how you can train your own models to use with your custom apps. I hope you've enjoyed this presentation. I'd like to thank all of the Claris Engage organizers, especially Steve Romig, Rosemary Tg, and Sherry Martinez, for their assistance in putting together what was certainly a difficult Claris Engage. I'd also like to thank the Claris community for all of their support over the years, as well as coming together to host a successful Claris Engage 2020. I look forward to seeing many of you in the future at other Claris Engage events.